Our program uses a single function to determine whether or not there is a stop or a yield sign in a given digital image. It does this by reading in the image, breaking it into its individual pixels, checking whether or not each pixel is red, and then using the properties of all of these connected areas of red pixels to determine whether or not they represent a stop or yield sign. And here's the physical code for the function sign detection. It reads in an image and then divides that image into its individual colors. It assigns those values to type double, which helps these ratios work as they're supposed to. The ratios are the levels of green to red, blue to red, and green to blue, and these help distinguish shades of red from other colors that might also have levels of red in them. Once it's done thresholding, we'll have a logical matrix which we pass to this function region properties, and region properties finds all of the bounded regions within the image, which would be all the instances of a grouping of neighboring ones, which would represent connected red pixels, which could possibly be a sign that we're looking for. We then scan through each of these regions and assign their dimensions to x and y, and test these to a set of given values, axis ratio and fill ratio. Axis ratio is x to y, and the fill ratio would be the area of the physical red region, like the number of ones to the actual area of the axes. If it passes those tests, then we crop the logical region and test for connected regions within it, and this could possibly identify red regions within letters within the sign. And this would help distinguish it from just solid colors like the red octagon in a stop ahead sign. We then check the number of regions within it and then check the fill ratios, which are unique to stop and yield signs, and do a surprisingly good job of determining whether or not a red region is a stop or yield sign. And once we pass those tests, it's a pretty good indication of whether or not it is actually a stop or yield sign. And we use a simple if-else statement here to check the fill ratio and determine which string to pass back, indicating whether or not it is a stop sign, a yield sign, or no sign at all. Here is an example of what is happening inside of the program. This would be an image that is passed to it, and this would be what the logical matrix looks like after it is passed the series of tests within the function. As you can see here, all of these red brackets are enclosing potential regions that the program tested, and in this case it successfully detected the stop sign amongst all of these other regions. This is an example of a particularly tricky case that was encountered with all these red trees. The red leaves create several different regions that have to be tested. Here's an example of the program actually working. You just enter a file name, evaluate, and it will tell you whether or not there is a stop or a yield sign in that file.
My name is Angelo Magliola, and I'm going to talk about the layout and the features of the graphical user interface. Alright, first off, we can see on our current folder here we have these images that are ready to be evaluated. And then in our command window, we can, if we type guide, we get our recently opened file, open it up, and here we have the figure. So we can see obviously there's on the left hand side here we have an enter file, which is our edit text box. We have a push button here that says evaluate, and then we have two static text boxes, one that displays the file name that you entered in this edit text box, and then one that displays the string that passes from the algorithm. On the right hand side, we see here a plot without the axis ticks to make it a lot cleaner. So if we press run here, we get this GUI that pops up that looks very similar. And then to see it work, we can enter a file that we saw in that command window, t15.jpg. Press evaluate, sees a clear yield sign here. It displays that string that it determined from the algorithm, and it displays the file name t15.jpg in this window here. Let's try it for one more just to see it used with a stop sign. We see here clearly a stop sign. There's even some discoloring, some other red in the picture, and it can still determine that it's a stop sign. And then it uses that file name and displays it here in this static text box.
So I will be explaining the programming portion of the GUI. After the layout is created, this .m file is automatically generated. And all that's left to do is to add the code that will actually make it execute the function that we want. So the first part that is manually edited executes as soon as the GUI opens. So that's right here. And all that does is remove the tick marks from the axes display, because all we'll be doing there is displaying the picture, so we don't need tick marks for that. And then the next part right here is what executes when the user enters an image. So this first part retrieves the image location and translates it into a string, which is then run through our sign detection function in the next line. So those are the first two lines. And then the image is set as a string, and then the image is read and displayed in the axes. So that's where we got rid of the tick marks before. So you can see the image. And then finally the output of the function, the sign detection function, is displayed as a string in the text 3. So what that means is the user will enter the location of the image, and then that will be processed through the sign detection function. The image will be displayed, and then so will the output of the function. So if there's a stop sign in the picture, it'll display that. If there's a yield sign, it'll tell you there's a yield sign, and if there's neither one, then it will say there's no sign. And because this was the only input available in the GUI, this is all we need code for, and we're done.